In this problem, we are to graph the trig function 3 subtract 2 sine x, but before we do that, the direction state we must first sketch the midline of the trig function. And if you look at the equation, it looks like my midline is going to be y equals 3. You could think of the 3 out in front as being the equivalent of having a plus 3 at the end of the equation, which would vertically shift the graph up 3, so that the midline is no longer going to be y equals 0, but rather it'll be y equals 3 instead. So we're going to click the icon that looks like a line, click anywhere along the line y equals 3, move over and pick a second point on the line. And although this line is not part of the actual graph, it's a very helpful reference in getting the graph of this modified trig function graphed correctly. Since I'm graphing the sine function, I'm going to click the last icon here, which allows me to choose a point on the midline. Had this been a cosine function, I would want to either start at the low point or the high point of the graph, and I would have chose this icon instead. But this problem involves sine, so I'm going to click this icon. This graph is not shifted left or right because you see no addition or subtraction in the parentheses here. So I'm going to start by clicking at the point 0, 3. Since my amplitude of my sine function is 2, I'm going to go up 2 units from there and move over. And you can see the shape of the sine function. Now if the coefficient and the sine were positive, this would be the correct shape of the graph. You would get the crest of the wave first and then the trough. However, my problem has a negative coefficient on the sine, so I must flip this upside down so that my graph starts out decreasing and you get the trough of the wave first and then the crest. So I have the shape correct, I have negative sine. I have the amplitude correct of 2 because my graph deviates 2 units above and 2 units below the midline. And I also have the midline of y equals 3 correct. The only thing left to do is to adjust the period. So if you notice, the coefficient on the x here is a 1. With a b value of 1, the period of the sine function should be 2 pi. So it should take 2 pi units to get one cycle of the trig function. And the way I've graphed the function, it looks like I've gotten more than 2 cycles of the trig function in 2 pi units. So I'm going to grab this dot down here and move it over so that it takes 2 pi units to get one cycle of the sine function. This is where having drawn the midline helps. I can start at the midline at x equals 0 and see that it takes pi units to get the first half of the cycle. I call this the trough of the wave. And there you can see it took pi units to do that. Then it takes another pi units to get the crest of the wave right here. And if you look down, you can see that that took 2 pi units.